Let's do another example with inverse Laplace transforms. In this example, you see in front of you here, you've got f of s equals to 3s plus 7, everything over s squared plus 9. Right? So we want to find the inverse of this function, which means you want to have an expression in terms of t, because you're converting back from s domain into time domain. So that means if we go back to our table, we are going to be moving from your second column back to your first column. Okay? So the way we want to approach this is you want to again look at your denominator first and find on your table where you can get something that has the same form as your denominator. You'll see you've got an s squared plus 9. So if you look at all the s squares, and you've got quite a few of them here, right? You've got s squared plus a squared, s squared plus a squared, s squared minus a squared, s squared minus a squared. Okay? So these two, number 5 and number 6, are not going to apply because of the minus sign, because your example has a plus sign in between. So you're going to be limited to either number 3 or number 4, right? And you'll see you've got s squared plus a squared. Your denominator in this case can then be written as 3s plus 7 over s squared plus 3 squared, right? Because 9 is the same thing as 3 squared. Now we move to our numerator because you want to find something similar to your numerator. And here you've got a bit of a problem because you've got two terms in your numerator, but on your table, your number 3 and number 4, they only have one term. Okay, which means you need to change the form of your function again. In this case, it's going to be fairly straightforward because all you need to do, is split up your numerator. So you can write that expression as 3s over s squared plus 3 squared plus 7 over s squared plus 3 squared. Right? You split it up into two parts. So let me write that over a bit bigger so you can see. S squared plus 3 squared, 7 over s squared plus 3 squared. Okay? Then, if we look at each of the terms, let's focus on the first one. You'll see your denominator, again, takes you to either number 4 or number 5. Right? Your denominator is in either one of those forms. Then we look at your numerator. You have an s in your numerator, which means that the form you're looking at is number 4 because you've got an s there as well. So your example for the first term is you can write like s squared plus 3 squared. Right? Let me just put the f of s down here so we're clear which function we're working with. Right? So that now looks like number 4 on your table. Yeah? Let's look at the second term. Your second term has a number in your numerator, and that number is going to take you to number 3 on your table, where you have an a in your numerator. So I can write that as 7 times 1 over s squared plus 3 squared. Right? But it doesn't look exactly like number 4, or number 3 on your table. Because if you look at number 3, you just fold this again so you can see. If you look at number 3 and you look at the denominator here, that a there must match with whatever is in your numerator, right? So here you've got a 3 in your denominator. It means you have to have a corresponding 3 in your numerator, right? And the way we're going to put that 3 in is to multiply by 3 in the numerator. Now, because you've multiplied in the numerator, you have to compensate with a third. Otherwise, you change the value of your function, right? So now, as it is there, that over there is going to be number 3 on your table. And if we now find your inverse, let's just fold this again. If we look at our first term, we said that transform looks very much like number 4, which means f of t is going to be equal to cos of at. Don't forget your 3, your constant value in front, so it's going to be cos. In this case here, your a is 3, so it's going to be 3t, plus the second term, the constant, multiplied by the form that you're working with here, again, is number 3 on your table, right, over there, where your a's match, numerator and denominator same as here, and that is going to be 3, so it's going to, the inverse of your transform is going to be sine of 3t. Okay, and there you have your answer.